right, this is section 4.2. We're going to be working on translating again today, which just means moving, shifting. Tonight's homework is page 350. We're going to do numbers 7 through 18. So let's get some notes for tonight's homework, and then we're going to go over the warm-up to make sure that we're good on that. So when we're translating some functions, there's some universal language that we use so that if you leave this classroom and trying to help somebody else outside of here, you're able to advise them on the same language. So I'm not saying something different in each period, or if you're helping somebody in another class with another teacher, we're all saying the same thing. If you're helping somebody at Whitney or at a different school, we're all saying the same thing. If you call your friend in the Philippines, we're still saying the same conventional language, okay? So that everybody can not have a different thing, so we're all helping each other out, all right? So when we're dealing with the transformations, there's some letters that we use to describe these transformations. We use A, B, C, and D. So I'm going to describe what each of these do. Thank you for taking out your highlighters. And then I'm going to ask you to take out your graphing calculators in a second. So if you have that, can you please take it out? So yesterday, we messed around with some of these letters, believe it or not. We actually did experiment with some of these already. What happened yesterday when I had a function, pretend this is the function. What happened when I had this function and then I just added to the outside of the function? Don't yell it out, just think. What happened when I added to the outside of the function? How did my parabola move when I added to the outside of the function? Now get some hands up, please. Let me count. We got 2 people over here. 3, 4, 5, 6, 7, 8, 9, 10, 11. We have at least one person in each group raising their hand. So can you please tell your group what happens when you add to the outside of the function? Okay, what do we call up and down? Yes, so this would be a vertical translation. Happy birthday. Somebody calling you to wish you happy birthday? Only because it's your birthday, I will do it. Believe it or not, we did experiment with one of these letters again yesterday. One of these letters helped us move left and right. Raise your hand if you can identify which one of these moves us left and right. I do have one person, at least one person in each group. Raise your hand. Make sure everybody in your group understands. Which one of these moves us horizontally? Noah, what'd your group think? Yes, letter C. Letter C is my horizontal movement. Take out your graphing calculators, please. Let's see what happens We make some more adjustments here. Let's see what happens when, let's go to A because B is the most challenging one. In your calculators, please go to the y equals button and press y equals x squared. Put that in your graphing calculators. In your graphing calculators, go to the y equals button and put y equals x squared in y1. Then in y2, I want to insert what we call an A. So what I want to insert is the number 5. Please insert the number 5 in y2. What happens when you put that 5 there? So in y equals x squared, y equals x squared. Where's that x at? Right there. But not, you don't want it up there, you want it as an actual variable. Y equals x squared, and then y equals 5x squared. So instead of x, let's keep our x squared here, and let's see what happens when we change this to a 5x squared. What do you notice? Did it move? Did it shift horizontally or vertically? What did happen? It got much, much skinnier. Okay? So I wonder what would make it fatter? Making it a negative? Let's make it a really small number, like 0.05. What happens now? It got wider. Very good. So if you can make a conclusive statement about what A does to your graph, did it translate it horizontally or vertically? No, what does A do? Parabola determines the width. Very good. We call that dilations. Okay? We call that dilations or expansions. So the A value determines the width or the thickness, or the width is the good word, of your parabola. I wonder what happens if you make A negative, though. What happens? So let's go over really quick. What happened when you made D negative? It just went down instead of up, right? What happened when you made C negative or opposite? Right or left? What happens when you make A negative? It flips the direction altogether. Okay? So we will call letter A direction and dilation. We're going to think of a better word for it later, but I want to be very clear that we understand. Now B is the one that we're going to go over at the end of next week because it's the most complicated or annoying one. Today, all you need to worry about are A, C, and D. Pretty easy? So on tonight's homework, I'm going to give you something like this. Example 1. I'm going to say, identify the values of C and D for the given function. Then describe the new vertex for f of x equals x squared. Now I know some of you guys are not used to reading cursive, so I'll read it one more time. Identify the values of C and D for the given function. Then describe the new vertex for f of x equaling x squared. So if I give you this function here, g of x is equal to the function of x plus 2 plus 10. Sorry. What you're going to tell me is what are the c and d values? Well, c is right here. And d is right here. So remember what we said about if it's inside the argument, you're not going to tell me that the c value is 2. The c value is negative 2 because that's going to tell me to move into the opposite direction. But the 10 you don't make opposite because d we do not make opposite. God bless you. So the d value is 10. Any questions so far? Positive 10. Oh, the actual question? Plus. Thank you. Any questions on how to find C and D? Okay. Don't forget there's a second part to your direction. Describe the new vertex. So what I'm expecting you to do is you're going to say the vertex will be shifted how many units? Am I going to be shifting to the left or to the right? 2 units to the left. Vertex will be shifted 2 units to the left. And if you're ever confused, didn't we already change? We already said C is negative 2. So if you take it, extract it from the equation, this tells you that this is the direction. This is the what you want to follow. 2 units to the left and 10 units in which direction? Up, 2, and then what is the new vertex? Negative 2, 10. What do you guys think? Doable? That's what the homework is going to be. So let me give you a B. Try to do that with your group. Describe this shift. I want to hear words like the argument. I want to hear words like vertical. I want to hear words like horizontal. I want to hear shifts. All right, guys, let's go. Here's our C. Here's our D. Don't yell it out, but just raise your hand if you can tell me what C and D are both are. Raise your hand if you have a response for both C and D. Got all 3, 4 people here. 5, 8, 10. Do you have an answer for me? You do? Great. Let's see your hand. Oh, lovely. Cyan, give it to me. What is my C value? Wait, how come it's not negative? Oh my gosh, I love it. What word am I looking for right now? Oh my opposite. What tells me that I'm going to do the opposite? What is that A word that we went over? One person knows? Wait, I heard somebody say it, but raise your hand if you know. What's she talking about? Something within something, so it's the opposite of the thing. You guys honey? It's inside the argument. Nicely done. So now we know that this is going to be the opposite. This is inside the argument of the function. This is outside of it. Okay? So then this becomes, just like Cyan said, a positive 3. And this guy is also a positive 3. Mina, read me your sentence that you would do on tonight's homework. What would you say? Three units to the right, 3 units up, 2, 3, 3. What do you guys think? Doable? All right. I want to go over last night's homework. I'm sorry, this week. Come on, Riad. Warm up. Is it showing? Good luck, guys. All right. The first graph from the warm-up is up on the overhead. Now I want to find which one is best describing the graph that is given. First thing I want to look at is the information that's given to me. They give me the vertex, and they give me the, what are these called? Or, what else are they called? Solutions, or zeros, or x-intercepts. They give me all of those things, okay? So what I want to do is I want to see which one has those x-intercepts in the equation, all right? So what is this x-intercept right here? -2, okay? That means I need to find which one of these functions, when I plug in -2, I should get a 0. That's why it's called a 0, because when you plug in -2, you should get 0. So if I plug in -2 right here, is this going to become a 0? Ew. Is this going to become 0? No. Ew. Is this ew times 6 going to give me 0? So is this going to be the solution to this function? It's definitely not the first one. Okay, how about right here? If I plug in -2, does this become 0? Convince me. What's -2 plus 2? Is this going to become 0? Yes. And this is 0. What's 0 times anything? And then how about this 0 times -1/2? What is that? So it could be this one. Y'all with me? Can it be this one? Why is it also possible to be this one? Because the 0 is, what is the 0? -2. When I plug in -2, I do get 0. You with me? How about over here? If I plug in -2, do I get 0? No, what's -2 minus 2? It's -4. And -4 times this, that's not going to give me 0. So my two choices are the two middle ones. Okay? And the same thing for -8. Isn't -8 going to give me zeros here? All right, now the question is my A -1/2 or +1/2? What did we say about the A again? What does it do? Direction and dilation. Okay, so if the direction is what helps me decide, is decided by A, then I should be able to just look at A and decide which one of these is correct. Which one is the one that made it face down again? Negative. So which one of these two does it have to be? This one right here. So now you're just going to write this equation for number 1. Easy? Now that you explained it, Ms. Riad, I know. I was actually really trying to assess how much you could remember from last year. And I'm so proud of this class in that you guys don't just like, you really try to divulge and then you help people in your group. So I was so pleased to see that after you guys stopped talking. All right, groups number 6. Now what information did they give me? Did they give me the roots? Yeah, that's not going to help me. What did they give me? A y-intercept. Very good. What is the y-intercept? 7, right? Which one of the 3 forms I can just look at and get the y-intercept? Which form I can look at and be like, whoop, that's the y-intercept. Standard form. Nicely done. So standard form, oh, I wonder how I could have figured that out. I don't, they're all in standard form. Okay. I could have just looked at the equation. All right, so which one of these has a y-intercept of 7? The first 3. Okay. How do I know for a fact, don't yell it out, but talk in your groups, how do I know for a fact it's not the first one? It's not the first one. It's not the first one. Why isn't it the first one? Group 6. Why is it not the first one? All of you can talk at the same time. I'm totally okay with that.
Because it's positive.
What's it? You gotta be careful. What's it? The parabola is positive?
I mean, the parabola is negative and the first one is positive.
Okay. So the first one is positive when the parabola should be, okay, what's it? What letter are we talking about now? A. Okay, so A should be positive. So it's got to be one of these two. Okay? How can I figure out which one of these it is, though? Eeny, meeny, miny, moe. You. Let's take a guess, 50 chance. How can I figure it out? Remember yesterday we did the dog passing through, right? So how about we pick a point that it passes through and see if it matches, if it works. So can you find me a point here that's literally on a corner? Because I see one right there. Do you see that? What point is that? 1, 4. If you're in seat A or B, please plug in 1, 4 to the second equation right here. If you're in seat C or D, plug in 1, 4 right here. And tell me which one of those is true. Which one of those, when you plug in 1, you get 4. All right, what did you decide? Is it, let's call this A, B, C, D. Is it B or C? When you plug in 1, you should have gotten 4, right? Which one of these, when you plug in 1, you do get 4? This one or this one? B or C? It is C. Okay, so when you plug in 1, now I can see some deer in headlights. I'm not really sure what's happening. Maybe your order of operations is off. But when you plug in 1 here, you don't make it negative and then square it. You square it, then you make it negative. So I have a feeling that's what you guys messed up on. We need to do another one, guys. Here we go. What form are your functions in for this one? Very good. Vertex form. If it's in vertex form, let's identify our vertex. What is our vertex here? 4, 2. Okay, talk to each other. Which one of these has the right form for a vertex at 4, 2? Talk to each other. Which one of these has the right form at 4, 2? All right, does this say vertex at 4, 2? Guys, talk to me, please. You're scaring me. Ready, 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 ready? Ready? Does this say vertex 4, 2? Does this say vertex 4, 2? Out. Does it say vertex 4, 2? Oh, so this and this says 4, 2? So this said 4, 2? This is negative 4, 2. Does it say 4, 2? What's your answer? What are your roots? Negative 2 and negative 5. So it's the opposite of what you think. How should it be written in your equation? Plus 2 and plus 5. Okay? Not that. Maybe that. Not that. Not that. What's my answer? The second one. B. Easy? All right. So now we should be able to identify. Give me a summary, please. Today I learned.